Okay, here we go. 6, 6, and this is called trapezoids. There's a second part, too, that you probably haven't talked much about in school at all, and that's called a kite. Now, maybe your teacher said go fly a kite or something, I don't know. But we're going to talk about kites. Okay, trapezoids and kites. So let's start with a trapezoid. I think I have one somewhere. Let's see. Trapezoid. Yep, I made it yesterday, and I still have it. Oops, what just happened? Control Z. Hold up. Alright, we found it. There's a trapezoid right there. Now, we did start talking about this a little bit yesterday. So, what did we say about a trapezoid? We said that it has exactly one pair of parallel sides. Exactly. Which means it doesn't have any more than that, right? If it had more than that, if it had two pairs of parallel sides, it wouldn't be a trapezoid. What would it be? It'd be a parallelogram, right? It'd be a parallelogram. This is a trapezoid which has exactly one pair of parallel sides, which means what has to be true about the other two sides? They cannot be, right? They're not parallel to each other, okay? So it has one set of parallel sides, and the other two sides are definitely not parallel to each other. Everybody got that? So that would be a trapezoid. We've got some words here. What did we call? We called these two sides, these parallel sides, we called them what? The bases, right? So that's one base, and this is another base. And then we also had the non-parallel sides, which are called the legs. That's very similar to another figure we've talked a lot about. It only had one base, though. Triangle. Triangle has base and legs and that kind of thing, or right triangle does anyway. A base and legs and that kind of stuff. All right, we got it? Okay, so that's a trapezoid. Let's see if there's anything else in here that I want to talk about as far as the trapezoid is concerned. Nope, that's it. That's basically all you need to know as far as the definition of a trapezoid. But what we're going to do, we're going to get a little bit more specific than just a normal everyday trapezoid. Oh, we did talk about the mid-segment, didn't we? Okay, it's a little bit later in the book, but let's do that right now. I think this might be a good time to talk about it. So, again, we did this yesterday. So it looks like if I just go over to right there, that would be the midpoint of that side. And if I go over like that, it's going to hit the midpoint of the other side. So what did I just do? I found the midpoint. That point right there is the midpoint, and this point over here on the other non-parallel side is also the midpoint. Does that necessarily mean that this segment from here to here is equal to this segment? No, it doesn't, okay, because this whole leg right here is not necessarily equal to this whole leg. You got it? Okay, so if they're not equal to each other, we say that these two can be the same, right, because I hit the midpoint. Hit the midpoint here, so these two are the same. All right, so I call this the what? Mid-segment. Very good. And we learned something yesterday about the mid-segment, didn't we? Let's I'll do this in this color again. Let's just call this A. I don't know if I did this yesterday. I don't think I did. We just put numbers in, didn't we? But I'll start with letters. What if I put this top is A, this bottom is B, and the mid-segment is C? There's a relationship between them. Well, it's not Pythagorean theorem. I don't have a right triangle here. So it's the average, isn't it? The mid-segment is the average of the two bases. How do I find the average of two things? Add them up and divide by 2. So what would this be in terms of A and B and C? It would be AB. A plus B. Right. AB would be A times B. You don't multiply them. You add them. Right? There's a big difference, isn't there? Okay, so I take the 2 on the top and the bottom, I add them up, and then I do what if I'm going to find the average? Divide it by 2. So I add two things together and divide it by 2. Would you agree? Yeah. So that's how you can find the mid-segment. Or you could do it like this. You could say we'll write it out. I don't know if there's a shorthand or a special thing for mid-segment. But the mid-segment is what? I could take base 1 and then take base 2, right? Call this one base 1, call this one base 2, and then do what to it? Divide it by 2. That's a little bit more general, isn't it? So that's how you find the mid-segment of a trapezoid. You just take the top and the bottom, divide it by 2. I like to think of it as just finding the average, okay? Because you know how to find the average of something. So if you just say, oh, the mid-segment's the average of the two bases. If you remember that, you should be able to figure this out. So let's stick a number in here. Christian, what's your question?
Oh, wait, what did you say? Wait, that says B what and plus B what?
Okay, I said it. You got to listen. I said B1 plus B2. I said that represents this base and this base. All right? I already said it once, but you were talking. I saw you. All right, so you got to pay attention when I'm teaching this. All right, because you would know that. So this is base 1, this is base 2, meaning it could be either this one or this one. It doesn't matter which order you add them up, does it? Let's just put some numbers in here just for fun. Let's make up A. What do you think that is? 7. All right, what do you think B? We'll make this easy. What's this? 11. All right, we'll say 11. This will come out nice and even. So if I wanted to find what C was equal to, or find the mid-segment, what would I do? And I would show the work, wouldn't I? So if you have a worksheet or you have a homework problem that asks you to do this, don't just do it in your head, write down an answer. I want you to show your work. So you would say 7 plus what? 11 and divide it by 2. So keep showing your work. That's 18 divided by 2. What's 18 divided by 2? It's 9, and so C is equal to 9. All right? Does that make sense? Watch this. What if... I was going to show you something, but I'll just do it like this. Let's change some things around. Let's make these completely different numbers than what we had before. Let's this time give the mid segment. All right, let's not make it too crazy. Make it 12's a good number. Let's make it 12. Okay, and let's choose this one up here. Now it's definitely smaller than this, so you can't be 19. Look, okay, it's shorter than 12. 2. All right, we'll say 2. All right. Now watch. What I want to do is I want to figure out what the other base is going to be. You could do it a couple ways. You could do it like this. Let me show you. All right. You could do the definition of mid-segment. Well, mid-segment equals the two bases added up divided by 2, right? Well, what is the mid-segment? This time I actually know the mid-segment. What is it? It's 12. So I could go 12 equals, then add the two bases together. Well, I've got 2 plus what? B over what? 2. So I could do that, and that's perfectly fine. I could throw it into my little formula, but then I'm going to have to do some algebra, aren't I, to solve for B. Watch the algebra. It's not that hard. Let's get rid of this bottom 2 right here first. How do I get rid of that? I multiply it by 2. Everybody see that? Okay, so what happens here? That cancels out. What do I get? 24 equals what? 2 plus B. All right? And then subtract 2 from both sides, and B is 22. All right? So that is equal to 22. Okay, right? All I did, I still used that same formula, didn't I, for mid-segment. This time I actually knew what the mid-segment was. So I stick that number in for mid-segment. There's the 12. My two bases. Well, I actually only know one of the bases. And it doesn't matter which one you call it. I just said this one is 2. I don't know what the other one was. Well, what did I call the other base? Just little b. So I put little b. What does the formula say to do, though? It says add the two bases and divide by 2, right? So that's what I did. So that's how I set it up. And then I just did some algebra. What did I do? I multiplied by 2, and then I subtracted one of the bases, didn't I? Okay? So look, if you can remember to do that, you may not have to go through that whole step right there. Watch. If they tell you the mid-segment, what do? You take that mid-segment and multiply it by 2, right? And then do what to it? Take away the other base that you know. What do you know? You know that's 2, don't you? And that works out, doesn't it? It's 24 minus 2 is 22, and that's what we have right there. If you can remember that shortcut. It's basically the opposite of this. Look, instead of adding and dividing by 2, we do the complete opposite. We do what? We multiply by 2, right? Instead of divide by 2. And then we subtract instead of add one of the other bases. Do you see that? If you don't really see that, because I'm not getting much of a response from you, if you don't really see that, then do this right here. Okay? That's what you should be able to do. All right? You should be able to do it whether you know the mid-segment and you're missing a base, or if you know the two bases and you want to find the mid-segment. You can always go to this formula right here every single time. Nick?
I thought again,
Well, but if you know the mid-segment, you're averaging these. Watch. 2 plus 22 is 24. Divided by 2 is 12. Okay, this time, see, I know the mid-segment. It's kind of like you know the answer, if you want to think of it. Like, see, this formula is written where mid-segment's by itself, right? So if I actually know the mid-segment, I have to do the opposite of finding the average. So I don't add and divide by 2. What do? I multiply by 2 and subtract the other base. It's complete opposite, isn't it? So if I told you, what is the absolute complete opposite of adding two numbers and dividing by 2? You would say timesing by 2 and subtracting one of the other numbers, okay? It's the complete opposite. And that's what we do to find the other side. If that still doesn't make sense, that's perfectly fine. Just use this formula and plug it into the formula. And then just do some algebra on it. But here's the steps. Make sure you practice that yourself. Okay? You know how I told you I was watching the calculus videos, you know? I was watching some even last night. And so I told Mr. Jackson, I was all proud of myself, you know? I thought he would be impressed, but I don't think he was that impressed. But I said, I've been watching calculus videos, and I said, I learned implicit differentiation. Now, wouldn't you be impressed if somebody told you that? Yeah, it is. I learned implicit differentiation. He says, oh, well, that's good. Basically, he's like, well, why are you doing it? I don't like just to learn it. I just wanted to learn it. You know, people ask me all the time, do you know calculus? I'm like, well, I used to, but I don't know it anymore. I just want to learn it. And he's like, well, make sure that you don't just sit there and watch the videos, that you do some problems. Get a book and do the problems. That's where you really learn it. And he's absolutely right. Same thing here. Don't know if I'll go that far. Actually, Khan puts questions on the website where you can actually go and answer questions to practice what he just taught. So I may do that, though. I may actually do that. I don't know if I'll break the book open or not, but so we'll see how it goes. So it's the same thing in here. My whole point of that story is this. If you just sit there and watch what I just did, you didn't really learn it. You're not going to learn it until you actually do the problems. And am I really learning calculus? Not until I can actually do some problems, right? And I haven't done that yet. I've just been sitting there just staring at the screen. But not just staring at it. I've actually been, I try to answer ahead of him, you know, when he says, okay, this is what we're going to get. I'm trying to do the problems a step ahead. And for the most part, I'm getting it. There's a few things I'm a little confused on, but for the most part, I'm getting it. But that's what you should be doing. You should be doing the problems, okay? It's very important that you do that. Okay. Let's try. We'll go green this time. All right, let's talk a little bit more. Actually, I'm going to copy and paste. Watch, this is another trapezoid, but this is a special type of a trapezoid. What do you think? I'll put it up here. Give you a hint? All right, I'll give you a hint. Well, first of all, I'm telling you right now it's a trapezoid. Or I'll do this. If I just did that right there, that's a trapezoid, agree? But it's a special type of trapezoid. It looks a little different than the other one that I did. Here's the hint. Here's the hint. Right there. It's not regular because all the sides aren't equal and all the angles aren't equal. So we don't really have a regular trapezoid. Still haven't heard the word yet. No. Okay, you're just throwing words. You're just throwing geometry words.
Give us another hint.
Here's the hint. Okay, look. Think back to triangles. Okay, think back to triangles. When you had a triangle, thank you very much. When you have a triangle, I know, but before you did. Trapezoids are actually, listen, watch this. Let's scooch this up a little bit. Trapezoids are kinda, they have a lot of similarity to triangles. Watch, if I took this and I stretched it out way up here, let's try to keep it parallel. Well, I'll tell you what, let's forget that. Let's do this. Let's ungroup it so I can grab one of these sides. This side right here. Watch this. I'll just show you. If I stretched it out, oops. If I stretched it out to here, then I took this side and I stretched it out, guess what it's going to make? It's going to make a triangle, isn't it? Okay? A triangle is kind of like, listen to this. A triangle is kind of, not exactly, again, some geometry teachers would freak out if they heard me saying this, but a triangle is kind of like a trapezoid, but it only has one base. Do you see that? If these are the two legs, that would be the base. If these two legs were equal to each other, what kind of triangle would that be? It'd be an isosceles triangle, wouldn't it? Okay, but this is not a triangle. It's a trapezoid, but it's a trapezoid two equal sides. So guess what it is? It's an isosceles trapezoid. Let's write that down. Do you remember how to spell isosceles?
Isosceles.
Isos, okay, or isos, and then C-E-L-E-S, right? C-E-L-E-S. Okay, isosceles, and this is not a triangle, it's a what? It's a trapezoid. Rhombus? When did we talk about rhombus? Okay, so it's an isosceles trapezoid, which means these two sides are equal. Now, being an isosceles trapezoid tells us a lot of stuff about this trapezoid that we didn't know before. All right, and let's change colors. Let's go to this green right here. Let's see the first thing. Here's a few theorems. You don't need to memorize, what theorem number they are or anything like that. I don't really care. Look at what it says. It says if a trapezoid is isosceles, and is it isosceles?
Yeah.
This one? Yeah, it is. Then each pair of base angles is congruent. Here's what I'm talking about. See this bottom base right here? What are the two angles that are formed by that bottom base? Well, this one right here and this one right here. I'll tell you what. Let's label it so we can refer to these things. All right, so D and C are base angles to this particular base. We'll call that base 1, and we'll call this one base 2. Is that all right? Does it make sense what the B1 and the B2 mean? It just means base 1 and base 2. So angle D and angle C are base angles to this base 1. Make sense? Because they both are attached to this base. If it's isosceles, what's true about those base angles? They're equal to each other. That's what this theorem says. So angle D is equal to angle C. Everybody got that? What else do you think might be true about this? Do you have any other base angles? Yeah, we got another base up here, don't we? So look at angle A. It attaches to this base B, B2, and this angle right here attaches. My arcs aren't looking too good today. But anyway, you get the idea. So these two angles right here would be what? Equal to each other. So angle A equals angle B. That's our first theorem. Our first theorem says that the base angles are equal to each other. You got it? So these two angles that are formed from this bottom base are equal, and these two angles that are formed for this top base, they're equal to each other. Okay. This is not a theorem, but we could probably figure it out. What do you think might be true about A and D?
Supplementary.
Why? Because, well, it's not just because one's acute and one's obtuse, but because you got parallel lines and a transversal, and what's the relationship between those two? There's a word for it. What is it? Consecutive interior angles. That's right. Consecutive interior angles are equal. So it's not really a theorem, but it is something that we know from this. All right, let's do another one. Let's see what this theorem says. This theorem says if a trapezoid has one pair of congruent base angles. So let's get rid of some stuff here. Actually, let's get rid of these. Let's get rid of this and get rid of this. Okay? All right, here we go. Let's read it again. If a trapezoid has one pair of congruent base angles. So look at this. This is a trapezoid, right? Because of the two parallel sides. And look at this. That's one pair of base angles that are equal. You with me? It says then, I'm sorry. Yeah, we don't know it's isosceles. All we know is that it's a trapezoid. So if I have a trapezoid with these two angles equal to each other, guess what's true about these two sides? They're going to equal, which makes it a what? Isosceles trapezoid. So watch. What it basically says is if angle D equals angle C, then it's an isosceles trapezoid. Let's write it like this. Then trapezoid ABCD is isosceles. Okay, write that down. Okay. So what did we know to begin with? We only knew that this was a trapezoid. We didn't know it was isosceles to begin with. Okay. Right? Are you with me? So we didn't know that this and this were equal to each other. The only thing we knew was this angle and this angle were equal to each other. So if I have a trapezoid, just an ordinary trapezoid, and I make this angle equal to this angle, that's going to make automatically this to be an isosceles. So if these two angles are equal, then guess what? Those two sides are equal, which makes it isosceles. Make sense? Okay, let's do another one. What haven't we used? Let's use this magenta looking color. Here's another theorem. And let's see what the other theorem says. It says a trapezoid is isosceles if and only if its diagonals are congruent. Alright, so let's go back to this picture. I don't know that's equal, I don't know that, I don't know that, and I don't know that. Okay? Now watch this. This is what it says. If I was to make some diagonals, let's make this that pink color. If I was going to do this, if those diagonals were actually equal to each other, and they kind of look equal to each other, don't they? Just take my word for it. Those two diagonals are equal. So watch. Basically, it says this. If AC is equal to BD, then guess what kind of triangle or what kind of trapezoid this is? This is going to be, what kind of trapezoid is it going to be? What's the only special trapezoid we've talked about so far? It's isosceles. Then, okay, we'll write it like this again. Trapezoid ABCD is isosceles. That's supposed to be a B right there. Is isosceles. Okay, so what does it say? If these two diagonals, if AC and BD, if they're equal to each other, okay, then this whole thing has got to be isosceles, which means what would be true? That must mean that AD must equal BC. Follow me on that? So if the diagonals are equal to each other, then this thing is an isosceles trapezoid. What do you think if we start off knowing that it's an isosceles trapezoid? Then the diagonals would probably be what? Equal to each other. That's right. So if I tell you that you have an isosceles trapezoid, then the diagonals are going to be equal to each other as well. All right. I think that's enough about trapezoids. No. We're always done in this class. What are you talking about? Let's do the other figure. What did I say the other figure was? It was a kite. Okay. Let's pause this and I'll find a kite. Okay, here's a kite. Now there's a few things that are true about a kite. First of all, it's a quadrilateral, isn't it? And I drew the diagonals in here. Now here's what it says. It says, let me get the definition. It says it's quadrilateral with exactly two pairs of consecutive congruent sides. What in the world does that mean? Well, it means not the opposite sides. Look, this side right here is opposite that. Do they look equal at all? No, not at all. But look at the ones next to each other. Look at this one and this one. Do you see how they meet right here? Okay, those two sides are equal to each other. And guess what else? These two sides over here are equal to each other because they meet at this common point right here. So it's the two sides that meet at this common point. Not this one and this one, all right? But these two are equal and these two are equal. If you have two pairs of consecutive sides that are equal to each other, then you have a kite. You got it? That's definition. That's the definition of a kite. Let's put some letters in here. A, B, C, D, and we'll call this, let's call it something else. Let's call it X. All right? Just be different. So look what we have. What's the definition? The definition basically says that AB is going to equal AD, and what else? CB is going to equal CD. All right? That's by definition. All right? We good with that? Then we got a couple theorems. Let's change colors for this theorem. I got it what? I got it wrong? Is that what you said? No? Okay. All right, look at this theorem. It says if quadrilateral is a kite, all right, this is a kite, just told you it was, and it's got the consecutive pairs equal to each other and stuff, then its diagonals are perpendicular. So what does that mean? That means this angle right here is what? It's a 90-degree angle. So this theorem says that, let's see, AC is perpendicular, line segment AC is perpendicular to line segment BD. That's what the theorem says. So it means you have a right angle right here. Everybody see that? So they form at a right angle. So that's true about every kite. When you draw the diagonals of every kite, it forms at a right angle. All right, let's look at one more theorem. And then this will pretty much be it for today. Let's try a little different looking color. Let's go yellow. Here's another theorem that says this. It says if a quadrilateral is a kite, yep, we got a kite right here. It says exactly one pair of opposite angles are congruent. Exactly one pair are congruent. That means the other pair of opposite angles are not congruent. So what do you think? Does it look like this big angle A right here and this big angle C are the ones that are congruent? Nah, that looks a lot skinnier than that one. So which ones do you think are congruent? Angle B and angle D. Now, did we figure that out just because we looked at them? Well, yeah, we kind of did. But there's, I don't know if it's a theorem or not, but I'll tell you one thing. Do you see how this angle connects the two sides that are not equal to each other? See it? Everybody with me? Look at this. See this angle? It connects this side with one arc and this side with two arcs. Do you see it? So the angle that connects the non-equal sides. Bailey, getting all this, are you? Good. Okay. It's a good way of paying attention. Looks relaxing, but I don't know if it's the best way to do it. Look at this. The angle that connects the two unequal sides. Eric, do you hear what I said? The angle that connects what? The two unequal sides, not the two equal sides, the two unequal sides. They're the angles that are equal to each other. So I could say that angle, we'll call it ABC, is equal to angle ADC. Yes. I've written it like 5 times. Yes, theorem. This is a theorem. All right, it's just a shorthand way of writing it. All right, everybody understand? What must be true about A and C? Big angle A and big angle C. They are what? They're not equal. No, look. Because on a kite, you only have one pair. On a kite, you only have one pair of opposite angles equal. On a parallelogram, you had 2, didn't you? But on a kite, you only had 1. A and C are definitely not equal to each other. Okay?
Come on, where's the worksheet? I know you got it.
I'll give you a worksheet to work on tomorrow, okay? So, it's Wednesday. Go to church tonight. And there you go.